This is Linrad in CW mode on 40 meters. And I'm listening to, I don't know, whatever it is, an AM station, and I've put the beat oscillator on the carrier. This is a preliminary study of the transceiver mode. I start the transmitter by clicking on this off to make it to on. And you can see there are dots at about 3 Hertz. It looks like this. You can see that the delay time is about 60 milliseconds. I have not pushed the delay, it's just convenient settings. Here is the upper track is the PTT of the Softrock, and the lower track is the audio that is going into the Softrock. What is special with this setup is what you can see here. This is a Perseus receiving the signal. The peak level is at about 0 on the scale, you can see here. And I can look, if I go, the bandwidth is about 2 kilohertz, and I move about 2 kilohertz to the side, like that, and you can see that's 70 dB. 2 more kilohertz. There are keying clicks, but they are about 80 decibels down. And I continue, and you can see the clicks are 80 dB down. They belong to what we see here. That's the carrier leak-through. Because in receive mode, the carrier is on this frequency, but on transmit mode, it is very close to the transmitted signal because the audio frequency is low. If I go on the other side, where the carrier doesn't sweep through, the keying clicks are weaker. The strongest spur is here, and that's the carrier, of course. Carrier leak through. I can adjust it to become smaller. Other spurs, there is this one. It is better suppressed than 80 decibels. And here is another one, and it's about 80 decibels. So this purity of this signal is fully adequate to use at medium powers, hundreds of watts. It's not much worse than traditional commercial transceivers. The Perseus spans here 0.5 megahertz. So this all looks good. What remains is to add a filter to remove the overtones. And that is a trivial thing which is standard for the Softrock. Here is the output from the sound card. You can see the keying sidebands, both in the spectrum and in the waterfall. If I switch off the transmitter, like that, you can see that there is a lot of hum and interference very close to DC. I did not care to make the ground loop things that I should have done to look with a sound card. That was not the primary thing for this study. I can switch on again and select another processing mode here, number 1. And you can hear there are some clicks because the muting is not adapted to this. But if you look here, the spectrum is even better. Because now the tone is closer to the carrier. If I go 2 kilohertz away and another 2 kilohertz, you can see the local oscillator leak through. On the other side, there are the key and clicks.